Hi and welcome back. In this video we are going to have a look at the hardware architecture of the open source switches and the proprietary switches. So in our demonstration we got an EdgeCore AS5712, which is a 48 port 10 gig switch with additional of 6 port 40 gigabit per second, which is based on off-the-shelf Broadcom Triedent2 switch silicon. On the other side we got a Cisco Catalyst 4948, which is a 48 port 1 gigabit per second switch, and we will have a look at the hardware of these two switches and we do our comparison. These two switches, they don't have similarities in the form of specification. So this is a 10 gigabit per second switch, this one is 1 gigabit per second switch, but it doesn't matter. That in this video we will be looking at the differences and similarities from the hardware architecture of these two switches. Alright, now let's have a look at the inside of the Cisco Catalyst 4948, the proprietary switch, and see what are the components and how the switch operates. Alright, so now we got the Cisco Catalyst 4948 switch open here. We have removed a few of these heatsinks so we can see exactly what is underneath. So one of the most important thing I want to mention here is that, this switch in general, all of the proprietary switches, they are all a bundle of the hardware and the software. So the software and the hardware of the switches, they are all bundled together. So if we make a line here that divide the switch in this way, this almost divides the software part, the control software part, which are sitting on the top, and the rest of the ASICs and the packet processors and the interfaces, everything on the side, in the downside. So here on the top, we have this CPU. It's a microcontroller. It's a Freescale microcontroller. It's a 32-bit Power PC from Freescale, which is acquired by NXP. And we got few memories, and also I think this one should be a flash memory, or maybe it might be the other one. And it also controls probably the fans, because that's a connector going to connect to the fan subsystem. So all the Cisco iOS software, the command line, everything, the routing software, like BGP, OSPF, spanning tree, everything runs here on this control in this microcontroller. And from here downside, these are all the real ASICs which are managing and processing the packet switching, packet manipulation, and all the functions which are related to the real packet switching. So between the CPU of this switch and the other components, it's normally it's like a PCI Express connection, within this PCB, which connects the CPU to the other components and also manage the main switching chipset. Now on the switch side, I mean this part, the downside of the switch, you see these are where the power supply comes. The power supply pumps the power, and these are all power component, the capacitors and the other components for that. This one is the main switching component. So all of these ports you see here in the front, the 48 ports here, and also the SFP ports, they are all being connected to the main switch. So the copper ports, to provide the copper ports, we need something called a PHY chipset. So here in this switch, it got 1, 2, 3, 4, 5, 6 PHY chipsets, which are providing the connectivity to these copper interfaces. The fiber interfaces, which are in general, let's say the SFP interfaces, we can have different type of SFPs. They don't need to go through the PHY ICs, because when you plug a SFP here, it includes also the PHY electronics. So the SFPs, they all just go directly to the probably RGM2 interface to the switching chipset. On the side, these are all probably memories like SRAMs, those GSIs, or the Samsung chipsets we have here. They are all memories, probably might be the cache or buffer or something. And here we got some more chipsets which are proprietary for the function of this particular switch model. So I think these are all network processors, the network processor chipsets for doing different functions like, faster packet manipulation, or, changing the information in the packets, or, for specific functions of this particular Catalyst 4948 might be related to all the four of Catalyst 4000 series. So the point I want to make here is that, in a proprietary switch, let's say it's Cisco or Juniper or, Brocade or whatever switch is that, they are a bundle of the hardware and the software itself. So you can't install any other operating system here and use that software to manage the switch. So it comes with the Cisco IO software. You cannot load anything else. Like, for example, you cannot run the Juniper Junos on this switch, or, something like Open Network Linux. So it's a bundle of the both. So let's have a look at the other switch which we got, the open networking disaggregated hardware, and see what the differences are. All right, so let's have a look at the inside under the cover of this open source switch and see what are the components and how it works and operates. All right, so now we got the open networking or disaggregated switch, this EdgeCore AS5712 switch opened, and as you can see, everything, most of the components are all modular. So we got power supplies here, we got fans and another power supply, separate fan board, and this is the main motherboard of the switch. Now the reason that these type of switches are called disaggregated or open networking is that these POM component, this PCB which you can see here, this is where the switch software, the operating system or the routing agents, all the software which is related to controlling of this main ASIC, they are all sitting here. And this is a complete modular, so it's a complete embedded PC actually. Underneath this heatsink, it's just a microprocessor. It can be Intel PowerPC or some kind of ARM processor. It got RAM, it got flash, and it got southbound interface drivers for PCI Express, which are connecting it to the main chipset. Also, it got to something called I2C, inter-IC communication, which manage the other chipset in this motherboard. So this part, is complete open, so you can install the open, kind of operating system on this switch, on this board actually, and using this operating system, the software which you are installing here, you can manage the chipset here. So the communication between to manage the flowing tables, the switching, all the components of this silicon here is through the software which you are going to run here. Let me remove the heat sinks and give you some better idea that how it looks. All right, so now as you can see, I have removed the heat sinks, and this is the Broadcom Triedent2 chipset under that massive heatsink. And all of these ports, as you can see here, they are all just connecting directly to the C chipset. So there is no PHY interface because this is just a SFP ports. So the SFPs which are plugged here, they have their own PHY. So there is no need to have a PHY chipset on the switch itself. And the communication between the CPU board and this chipset, the main switching chipset, the Broadcom Triedent2, is via PCI Express communication. And they got the other components. These are all of the other CPLDs which are managing. They can manage the SFPs here. They can read and write. They can read actually the SFP information from on the front ports, or managing the LEDs. It's got all of these LEDs also in the front, managing the LEDs. And the other functions of the switch. Here we got also management ports here, and also a console port. So this particular chipset, you see here is a small PHY, which is for that management interface, and that serial connection also is being routed all the way back to the CPU. All right, and this CPU module is also removable, so you can remove it from the board. And as you can see, it's a complete embedded PC. As you can see in the center, we got here an Intel Atom processor, and on the top we got its memory module, which I think that's a 2 modules, each one 4 gigabytes, a total of 8 gigabytes of memory. And here on the right side is a flash memory, where whenever you install any operating system on this board, you know, that software, the operating system will get installed inside that flash. And this is that connector which connects this PCB to the main motherboard of the switch. So in general, you can load any open networking operating system on these switches, like Cumulus or Open Network Linux. All right, and in this drawing, just showing you that, you know, the architecture of these open networking or disaggregated hardware switches, because mostly they are all similar. So the main difference is the type of the packet processor ASIC, which are, you know, different in terms of the supported ports. So they may come with a specific switching capacity for having 1 gigabit per second port, 10 gig, 40 gig, 100 gig, you know, up to 400 gig, based on the switching silicon. And mostly they support different type of SFPs or QSFPs or different stuff. Some of them they come with the PHYs also, you know, with the 10 gig 10G base T, or, you know, even 1G base T. But in general, they all have the embedded x86, or it might be also based on the PowerPC or ARM processor, which are separately connected to the main motherboard. Now, in the CPU board, you have the ability to install different operating system using the ONI interface, which is already installed inside this CPU board. So ONI, the Open Network Installation Environment, that allows you to install this type of operating system. So you can install Pika 8 or Cumulus Linux, OpenSwitch from Linux Foundation, Open Network Linux, or even the Big Switch Network, the Switch Lite, I think. All right, so now let's have a look at the ONI, the Open Network Install Environment, and I have connected a console to the switch, and I'm going to power up the switch and see what we will see from on the screen of the ONI. Okay, so now the switch is powered up, and let's see what will come on the screen. Okay. So we got initialization, and we got the option to go to the BIOS of the switch. So as I explained, you know, it's just like exactly an embedded x86 machine. This is a standard BIOS where, you know, you can do some basic configuration. You know, here we got more options because it's an embedded PC, so you can do more configuration on the behavior of this embedded machine. The configuration of the North bridge chipset, South bridge. So the South bridge chipset has the PCI Express ports where the PCI Express are, you know, one of them or maybe more are connected directly to the switching ASIC on the other board which we saw. And there is nothing really that, you know, we want to change here, but let's just exit from the BIOS and let the switch boot up. So this is the default. So when you get the switch, this disaggregated switches just from the factory, it just comes with the grub menu. So it has some embedded flash inside, which is loaded with ONI and this grub menu. So ONI will let us to do the installation of the operating system. You can uninstall the operating system, and the other options are for updating the ONI itself or doing some kind of rescue. So if I go to install OS, so a fresh small Linux kernel will load. So the kernel loaded, and it brings up the flash memory. So flash memory is loaded, and it lets us use the management interface for loading the operating system on the switch. So it brings up the Ethernet 0, which currently is not connected to anywhere on this switch right now. And once, if the Ethernet 0 is off, it tries to get the IP from the DHCP, or you can just set IP statically. And once that is done, you can use ONI to install an operating system, to download the operating system using TFTP, FTP, or any other method. There are a few commands from ONI, so let's do /bin, for example. We got BusyBox, that is makes the life much easier. We got install URL. So this command is a very important command in ONI, which tells ONI that, you know, I want to install an operating system, and you have to go and use TFTP, FTP, or HTTP to download the file for me. So if I say FTP : / 1.1.1.1/000, now it tries to download that, but however we don't have any Ethernet connection. The other components, like, you know, ONI discovery start. So this command actually restarts the discovery process. So it starts with trying to get the IP address on the Ethernet 0, and then if the IP address is received on the Ethernet 0, it tries to fetch the default firmware for the switch, which is a file starting based on the MAC address of the switch itself. If I do the ifconfig, also we can see that Ethernet 0 is here, but it's not connected to anywhere. So using the ONI install environment, we can load this open networking operating system like Pika 8, Cumulus Linux, Open Network Linux, OpenSwitch, and other operating systems for the open networking switches.